This is section 4.1, part A, right triangle trigonometry. The I can statements for this section: I can find values of trigonometric functions for acute angles of right triangles, and I can solve right triangles. There are 6 trigonometric functions. They are sine, cosine, tangent, cosecant, secant, and cotangent. We abbreviate sine as sin. So the sine of theta is equal to the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite over the adjacent. Now cosecant is actually just the reciprocal of sine. So it is, we abbreviate cosecant, it is CSC. And it's the hypotenuse over the opposite. The secant is the reciprocal of cosine, so it's the hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it's just adjacent over the opposite. Now, like I said on the previous slide, we do have reciprocal functions. These are just functions that are the reciprocals of the 3 trigonometric functions that we're used to dealing with. So cosecant is just 1 over sine, secant is 1 over cosine, and cotangent is just 1 over tangent. Now, we look at sine and cosine. Sine is opposite over adjacent. Cosine is adjacent over hypotenuse. Remember, when you have a fraction over a fraction, you flip the second one and you multiply. So we would have the opposite over the hypotenuse times the hypotenuse over the adjacent. The opposite and the adjacent will be what you're left with because the hypotenuse will cancel. So that's opposite over adjacent, which is actually the tangent function. So if you ever have sine and cosine, sine divided by cosine is tangent, or cosine divided by sine would be cotangent. So if we take a look at this expression, at this triangle, we're going to come up with our 6 trigonometric expressions. So the first thing we need to do is to label the sides of the triangle. If this is my angle, the side across from the angle, we name the opposite. The side that's between the angle and the 90 is the adjacent, and the side across from the 90 is your hypotenuse. Sine is just the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is opposite over the adjacent. Cosecant is just the reciprocal of sine, or the hypotenuse over the opposite. Secant is the reciprocal of cosine, or the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent, or adjacent over the opposite. So these are our 6 trigonometric functions for theta on this triangle. Now we need to find the remaining 5 trigonometric functions if we know one of the functions currently. So if this is our triangle, cosine, remember, is the adjacent over the hypotenuse. Our adjacent side is down here. Our hypotenuse is up here. We need to find the opposite side. If you know 2 sides of a right triangle, you use Pythagorean theorem to find that third side. Remember, the C is the side that's across from the 90. So we know that third side is going to be the square root of 21. So now we just need to find the values of our 6 trigonometric functions. We already know that cosine is 2 over 5. Since secant is the reciprocal of that, that one's just going to be 5 over 2. Sine is the opposite over the hypotenuse. Tangent is the opposite over the adjacent. Now cosecant is the reciprocal of sine, or it's the hypotenuse over the opposite. But we can't leave a radical in the denominator. If you have a radical in the denominator, you move the radical to the top, you leave the number on the bottom. So this one will be 5 radical 21 over 21. If the 5 and the 21 could reduce, we would do that, but in this case they are in their simplest form. Then cotangent is adjacent over opposite. Again, we have a radical in the denominator. So when you have this, you bring your radical to the numerator, and you leave the number that's inside the radical in the denominator. So we would simplify this to be 2 radical 21 over 21. Now we do have some specific angles that we know what the sine, cosine, tangent, cosecant, secant, and cotangent are without having to solve them. So for any triangle, when you have a 30-degree angle, the sine of a 30-degree angle is 1 over 2 when you simplify it. The cosine is radical 3 over 2. Tangent is radical 3 over 3. Cosecant is 2. Secant is 2 radical 3 over 3. And cotangent is radical 3. We have the same values we can find for a 45-degree angle and a 60-degree angle. We'll also talk about this more when we get to the unit circle. But not all values are ones that are easily known. We do have to calculate some of those. So if we take a look at this example, we do need to find the value of x. Right now this is our angle. X is between the angle and the 90, so this is the adjacent side. The 18 is across from the 90, so that's our hypotenuse. So we need to decide which one of our trig functions uses adjacent and hypotenuse, and that will be cosine. Now we know our angle is 42 degrees, so that's going to go in for our theta. My adjacent side is x. My hypotenuse is 18. Now we just need to solve and get the x by itself. Right now this is x divided by 18, so we do need to do the opposite. Opposite of divide is multiply, so we are going to multiply both sides by 18. So we're left with x is equal to 18 times the cosine of 42 degrees. Once you make sure your calculator is in degrees, you can put this into your calculator, and you should get x is equal to 13.4. If we take a look at another example, here's your angle or your theta. We're given the side across from that, which is your opposite side. And we're looking for the side that's across from the 90, which is your hypotenuse. So the trig function that deals with opposite and hypotenuse is sine. We know our angle is 63 degrees. Our opposite side is 200. My hypotenuse is x. Now we need to get the x by itself. Right now we have division, so I can multiply both sides by x. So now we have x times the sine of 63 is equal to 200. Now it's x times the sine of 63. To get the x by itself, we're going to divide both sides by the sine of 63. Once again, make sure your calculator is in degrees. And if we calculate this, 200 divided by the sine of 63 will give us 224.5 feet. We have inverse trigonometric functions. These are used to find the measures of the angles. So if we have the sine of theta is equal to x, and you want to find the value of theta, to take the sine to the other side, you use the inverse. We would do the exact same thing for cosine and for tangent. So anytime you are looking for an angle measure, you will use the inverse of your trig function. So if we look at this example, here's my theta. The 26 is across from that angle, so that's the opposite. Between the angle and the 90 is the adjacent. Which trig function uses opposite and adjacent? That will be tangent. So when we fill this in, we're going to be left with the tangent of theta is equal to our opposite side over our adjacent side. We're looking for our angle. We want to take just that tangent to the other side, so we're going to use the inverse. We're going to go ahead when we find our angles and round them to the nearest degree. And if on your calculator you do the inverse tangent of 26 divided by 11, you will be left with 67 degrees.